Bismillah ar-Rahman ar-Rahim and Assalamu alaikum. Now the second lecture of chapter number 2, the modern periodic table. Now let first of all a brief history that this periodic table was introduced by Moseley in 1913, and he arranged the elements according to their increased atomic number. It means that as the atomic number of element gradually changes, the physical and chemical properties of element will also change. For this purpose, he present a law which is called the modern periodic law. According to this law, the physical and chemical properties of element varies as the atomic number of element varies. With the change in atomic number, the physical and chemical properties gradually changes. Or we can also define it, state the law, the physical and chemical properties of element are the periodic function of their atomic number. So according to this law, he arranged the elements in periodic table, and he designed the periodic table by arranging the element in groups and periods. We will discuss the modern periodic table, the groups in modern periodic table, as well as the periods in periodic table. So first of all, let we start briefly what are groups in periodic table and how many groups of periodic tables are there. The vertical columns in periodic table are called groups. Each group is further divided into subgroup A and subgroup B. The elements belongs to subgroup A are called normal element, or they are also called representative element. Similarly, the elements in subgroup B are called transition elements. Now the question arises that how and why the elements are grouped together. Remember that elements are grouped together due to similarities in their properties, and the similarities of element in groups is because of the same valence shell electronic configuration. It means that if element has same valence shell electronic configuration, they will group together in a same group and they will possess same chemical properties. Now, dear student, look at this. These are the element of first A: lithium, sodium, potassium, rubidium, and cesium. The atomic number of lithium is 3. The electronic configuration of lithium is 1s2, 2s1. Similarly, electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. The total 11 electrons are arranged in sodium. The atomic number of potassium is 19. So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So if we look at the valence shell in lithium is second, the valence shell in sodium is third, valence shell in potassium is fourth, and all these valence shell occupy same number of electron. So because of the same number of electron in the valence shell, all the elements of first A element will have same chemical properties. So if we look at the general electronic configuration for first A element, it is NS1, where N is equal to valence shell. Now the question is, what beryllium, magnesium, and calcium has same chemical properties? So your answer will be these elements belongs to same group. They will have the same valence electronic configuration, and because of the same number of valence electron, they will have almost same chemical properties. Now look at this. This is the modern periodic table. Group A elements, and in the middle of periodic table there are group B element. So first A, second A, third, fourth, fifth, sixth, seventh, and eighth, these are the elements belong to subgroup A, and they are called normal element. They are also called representative element. Similarly, the group B, subgroup B, which are called transition element, and they are starting from first B, second B, then third B, fourth, fifth, sixth, seventh, and look at this. The eighth B group consists of 3 groups. So these elements are called the transition element. The total number of groups, group first A as well as group A and group B are called group A and B are all together, and we have 18 groups in periodic table. Periodic table is also divided into families. For example, first A element are called alkali metals. The second A elements are called alkaline earth. Similarly, the third A element are called boron family, the carbon family, the nitrogen family, the oxygen family, which is also called chalcogen, and the seventh A group, which are called halogen, and at the end the eighth group element are called noble gases. Similarly, periodic table has been classified into blocks. For example, S block element, P block element, D block element, and F block element. The blocks in periodic table is because of the presence of valence electron, whether they are in S subshell, P subshell, D subshell, or F subshell. Elements in which S orbital is in the process of completion are called S block. First A and second A element are called S block element. Similarly, element in which P subshell is in the process of completion are called P block element. They are from third A to 8A. Similarly, those elements in which D subshell of the second last shell is in the process of completion are called D block element, and they are in the middle of the periodic table, while the F block element are those in which F subshell is in the process of completion, and such element are in the bottom of the periodic table. Now remember that there are 2 groups of S block element because there are 2 electrons in the S subshell. So S subshell occupy maximum of 2 electrons, therefore it will have 2 groups. Similarly, P subshell occupy maximum of 6 electrons, and they have 6 groups in periodic table. D subshell occupy maximum of 10 electrons, and they have 10 groups in periodic table. Similarly, 14, etc. Similarly, F subshell occupy maximum of 14 electrons, and they have 14 groups in periodic table. Look at this. These 2 are S block, they are P block. So from 1 to 10 D block, and from 1 to 14 they are F block.